Hi. In this video, we'll take a look at loading images into processing so that we can display them in some sort of interactive form. I've got my processing window open here, and I've also, in my downloads folder, located two images that we'll be able to use for this example. I'm going to start by just copying their current location. You can see it's in my downloads folder. And if I go back to processing, under the sketch menu, there's add file. And this is where we can import content or images or other data that we might want to incorporate. So I'm going to paste the path. This is the location. It's going to move me to that folder. You can navigate here however you want. And I'm going to select, the left image. It looks like it's going to make me do them one at a time. And then I'm going to add another file, the right image. Now what is happening here, if I look at the folder for my sketch, I've called image demo, all that's done is it's created a folder called data, and it's copied and pasted those two images here. This folder is where this sketch will always look for any imported image files that we want to make reference to. So you can use that menu that's right inside of processing, or you can just manage it yourself. I could copy and paste files into this folder, and then processing will have access to them. You may or may not have noticed these were PNG files. That's a popular file format because it preserves transparency. So if we want an image that isn't going to have a solid colored background, that's a good way to go. Alright, now to incorporate use of these images, there is a data type called pimage that is built right into processing. And that's a capital I actually. So we're going to declare that we will use a variable, and I'll maybe call this just lion L for lion left, and we'll say we're going to use another p-image. It's going to be lion R, and in our setup function we'll actually load those images and store them in those p-image type variables. So I could say lion L is going to be equal to, and this is a function. We can look this up in the processing ref, but I'll just provide it for you today. We can use the image load image function, and we simply need to give it the correct name of the file. So I called mine lion-left.png, and then that's passing it in as a string type, so make sure that we've got that within our quotations. And if I wanted to display it, we'll just put one on the screen for right now. The image command allows us to draw an image at a certain location. So I will say let's draw the image that's stored in the pimage variable lion L, and let's draw it at mouse X for its X coordinate and mouse Y for its Y coordinate. And I'm going to add one extra line here. I'm going to add image mode, and this is a function that changes how it calculates where it's going to draw images on the screen. And because we are going to put it on our mouse cursor, I'd like it to center the image on our mouse cursor. So if I were to hit run on this sketch, we should get an image, and then you can see it's drawing our lion over and over on the screen. Now that might look a little bit more comprehensible if we were to redraw the background every frame. So let's just draw, we'll fill it white every time, and that should let us better see what's going on with our image. And now we can see that the center of the image is aligned with the center of my cursor, and we can navigate this around on the screen. Now we've got two images here, one a left-facing line and one a right-facing line, and this would be almost our simplest case for what we call a sprite, where we've got more than one frame of animation. In this case, I really just want to use my left-facing line if I'm moving it in the left direction, and I want to use the right-facing line if I want to move in the right direction. So to do this, first of all, we want to load in our second image. We'll store it in a variable lion R that we've already declared. So we use the load image function, and we've called this one lion_right.png. And we're going to need to add a little bit of logic to decide which one we should be drawing on the screen at once. So to do this, maybe let's introduce a Boolean variable, and we may want to call this moving left. How about? We need to initialize moving left to some value. Let's set it to be equal to true. This is almost arbitrary. We can choose whether or not we want it to start facing left or right, and then we'll modify that based on our user input. Now instead of just drawing this image to the screen, line L, we want to add a condition here. It's going to choose which one should we be drawing, the left or the right image. So we could say if moving left is currently set to be equal to true, then we should be drawing our left facing line. If, well, we could actually just say else, right? In the case that it's not equal to true, we should draw our other line. So we can draw line R at mouse X and mouse Y. Now, since we haven't added any mechanism to change the value of moving left, right now this should actually give us the exact same behavior as our last program. Every time through the main loop, moving left equals true. This will be a successful condition, and so we should always be drawing the left facing line. So we can just do a test and we can see that this is basically the same. Now the last thing that's left for us to do here is just to determine a way in which we can figure out if the user has moved the mouse to the left or moved the mouse to the right. Now a very handy mechanism that's built into processing is just like the mouse X and mouse Y that track our current mouse position. We also have P mouse X and P mouse Y, which store the previous mouse position. So from one frame earlier, it keeps track of where the mouse used to be. And just with those two values, we can track which direction the mouse is moving. For instance, if our previous mouse X value is greater than our mouse X value right now, that's going to tell us that the mouse is moving in a left direction. Conversely, if the P mouse X value is less than our mouse X value, that shows us that we're moving in a right direction. And there is a third case. If P mouse X is equal to mouse X, then we've had no change. And so really there's just those three different possibilities that we should consider each time through our draw loop. Okay, and so we can just build in our conditions right here, and depending on which condition is true, we'll either be changing the Boolean variable moving left, or we'll be leaving it the same if the user hasn't moved the mouse at all. So let's say if P mouse X, so our previous mouse X value is greater than our current mouse X value, this is the case where we're moving left, so we can just set our moving left Boolean variable to be equal to true. Else if our P mouse X value is less than our mouse X value, I'll maybe just put a space there, then our moving left variable is going to be equal to false, right? Instead, we're actually moving to the right. We don't need to add an else statement because in the case that we're not moving left or right, we just want to leave the value of moving left to be whatever it used to be. So if the line was pointing to the right and we haven't moved the mouse, we want to leave that variable in the same place so that it's not going to flip the image on us. Alright, if we hit run, we can now see that if we move the mouse in each direction, the sprite is going to flip back and forth. As I said before, this is a pretty simple sprite animation. Typically in interactive programs, you'll actually see that maybe if a character is facing in one direction and it's moving, it should be cycling through a series of frames pointing in that direction, and so the complexity gets a little bit bigger than in this simple example, but it's also not out of reach. Alright, I hope that worked for you, and we'll keep moving on to the next project.